Provide a counter example to justify each of the following false statements. Every matrix is row equivalent to a unique matrix in echelon form. This is false. This in fact, this is true in reduced echelon form. Okay, if we had reduced echelon form, then this should be true. Now, not a unique, so we wanna make one more than one. So suppose we have a matrix 4 6 and let's say 4 7. Now I can row reduce this matrix. So this is 4 6, then subtract 0 1. So this is in echelon form. Okay, we have a pivot and pivot. So this is in echelon form. At the same time, we can go further and divide first row by 2. We get 2 3 0 1. This is also in echelon form for this matrix. So for this matrix, we got one echelon form and another echelon form, and this is not unique. So not unique. Any system of n linear equations in n variables has at most n solutions. So let's say, this is wrong. Not at most n solutions. We can have, in fact, infinitely many solutions. So I want to show this with 2. And not at most n. I want to show infinitely many. So let's say x plus y is 2 and 2x plus 2y equals, I'm just writing same line. In fact, x plus y is 2, multiply by 2, we get 2x plus 2y equals 4. Okay, they are same. So if we graph, we get the same line. Okay, I don't know, something like this. Okay, I mean, this is not true. What I wrote, that's not true. But let me show you by matrix, because this is 1 1 2, this is 2 2 4. If we row reduce, we get 1 1 2, and this is 0 0 0. Okay, so we have a system of two linear equations in two variables, x and y, and if we row reduce, we can clearly see we get a free variable. So how many solutions are there then now? Infinitely many solutions. Because when we multiply this by a number, pretty much no information. So we have x plus y equals 2. So free, we can take anything and you still can find x. So infinitely many. I mean, if you just write this equation and infinitely many solutions, that would do it. So if A is an m by n matrix and the equation is consistent for sum B, okay, here's a sum, not for all, sum B, okay, obviously that comes from Rm, then the columns of A span Rm. So we should be able to see the columns of A span Rm. Now we take a vector in Rm, and that should not be a linear combination of columns of A. Okay, so we just failed that. So let's do this for 2 by 2. Then this is also R2. Okay, so we should have a consistent system. Let's say 1 1 2 2 and 3 3. So this is a consistent system. Okay, for sum B, for 3 3, okay, this one is consistent, because if we try to solve, we get 1 2 3, now 0 0 0. That's good. Consistent means we, in this case, in fact, we get infinitely many solutions. So consistent. But if we, then the columns of A span R2. R2 means if we take any vector in R2, that cannot be written as a linear combination of these two vectors, columns of A, because this is our A, because AX equals B. Let's see the following: 1 1 2 2. If I take R2, let's say anything not equal, let's say 1 2, okay, that's in R2, and if I try to write 1 2 as a linear combination of 1 1 and 2 2, that means I write 1 2 here. If we try to solve this, we get no solution, inconsistent, because it will be 1 2 1, 1 minus 1 0, 2 minus 2 0, 2 minus 1 1, 0 0 0 equals 1. So this is inconsistent. Inconsistent means this vector is not a linear combination of these two column vectors. So we cannot span R2, because I took 1 2 and then it's not working. The whole idea is we have the same vectors. Look, 1 1 2 2. If we graph that in R2, they produce same line. So here is U, V, and W are non-zero vectors in R2. Okay, are non-zero vectors. Then W is a linear combination of U and V. That's not true, because U and V could be linearly dependent, exactly like this. Look, if we take U 1 1 and V 2 2 and W, I can just take 1 2. Now I got U, V, and W in R2, but this W is not some constant times 1 1 plus some constant times 2 2. Okay, we cannot. If you try, it's gonna go like this. Okay, but what is true though, if we have U and V linearly independent, unlike this, linearly independent, then any vector could be written as a linear combination. That would be true. So it does not say anything about U and V, so that's false. No, not a linear combination.